Hi guys, I'm Darren and welcome to the next installment in our INAV 5 Beginners Series Academy. So before I get started on this video, I just want to apologise if I make any strange sounds. Some of you may have seen on my Instagram feed that my chair is a little bit knackered. So if I accidentally sort of move backwards and make a weird noise or whatever, just ignore it. This is the next video in our INAV 5 Beginners series. If you haven't seen any of the others, I'll put a link to the playlist in the video description, so go and check those out. In this video, we're actually getting on and setting up INAV finally. But if you've been paying attention, you will notice that there's a new version of INAV out, INAV 5.1, and it's well worth updating to this if you're on INAV 5.0. If you installed INAV 5.1 because it was the latest release, you can just skip ahead to the next part in the video. But first, what we're going to do is, because we haven't changed too many settings, we're going to update to INAV 5.1. So first, what we need to do is download the new configurator. This is from the same location that we downloaded the INAV 5 configurator from, and you'll notice in the release, the latest now is 5.1. So we're just going to click on that, go down to the assets and download the version we want for our system. So let me just stick that on the desktop and I'll be back soon. Right, so we've got configurator. So what I'm going to do just for this video is I'm just going to extract it to the desktop, and then I can delete the zip file. And what we're going to do is just open this and run INAV configurator. Now, I believe in the earlier video I showed you where I put it in program files just so everything's neater, and renaming the icon to change the version number. So I won't go over all that again, but of course that's what I would do. So the plane is on the desk, we've got INAV configurator installed. The first thing I want to explain is why it's a good idea to update. There have been some occurrences where people have powered on their flight controller only to discover that their complete configuration has been wiped. Now, this might sound like a bug, but actually it isn't. What INAV is doing is detecting that the configuration that's on the flight controller is corrupt, so there's a problem with it, and that causes the wipe. What causes the configuration to be corrupted can be a variety of things, but the usual suspect is going to be a bad save. And the reason the save can be bad could be because of a power spike, because the USB cable has been knocked, which is less likely with these USB Type-C, but the older micro USB, especially on flight controllers with a vertical port, that they can move about, and that can obviously corrupt data. But also just unplugging your battery too soon when the firmware is still saving. In INAV 5, a new feature was added, which basically meant that you didn't need to calibrate the gyro every time that you plug the battery in. But every time you plug the battery in, it would do a save. So INAV 5.1 removes that save every time you plug the battery in. The fewer save commands that go through, the fewer chances there are that the configuration can get corrupted. So that's why this is a good thing. Now, this may have particularly affected people who are using Express RRS, because for that system, one of the ways to get it into a binding or Wi-Fi mode is to plug in and unplug the battery a few times in succession. If you're doing that, there's a good chance that you're going to corrupt the save file. So this is a good update. There are a couple of other tiny little things to just general improvements, but that's the main reason. So let's get on and do the update. So the first thing I'm going to do is just plug in the USB cable. And what we're actually going to do first is connect to INAV. See, this chair's going again. Ah, interesting. My flight controller has actually been corrupted by the looks of it. So it's a very good thing that I'm doing this change. So let me just check what settings are there. So the accelerometer has been completely wiped. So yeah, my flight controller has actually just demonstrated exactly why we want to update to INAV 5. Forgetting what's on my screen right now, what we need to do is, if everything is still okay with your flight controller, is go into the CLI, and what we're going to do is type in the command diff all, and this will actually produce all changes that you've made on your flight controller. So you can see there's absolutely no changes here well, pretty much no changes from defaults whatsoever, because the configuration has been wiped. So what you would actually do is choose save file and just stick it on your desktop, give it a name that you know. So maybe we'll put in Dolphin and then click save. Obviously I'm not going to do this because there's nothing to save, but I will pull up an old diff file from a different model to show you what to do in the next step. So once you have the diff, what we're going to do is disconnect and pop into the firmware flasher. Now we need to choose the correct target from our flight controller. So this here is actually a diff from my Albabird, and if you open up the file that you've just saved from your Dolphin, you'll find at the top this version here. So we have INAV, which is the firmware, and then we have the flight controller. On my Albabird, it's an F405 wing, so the target is F405 SE. I know on this it's going to be the Maytech H743. So I'm going to type in Maytech H and that will pop up. Once you've selected your target, this is the same as when we were first setting it up, but now we're going to obviously choose INAV 5.1.0. If there is a more recent stable release, feel free to install that. And we're just going to make sure that full chip arrays is on. Next, click load firmware online, and finally flash firmware. This will wipe the firmware and the settings off of our flight controller and install 5.0. So when this finishes, we are on a complete back to basics original INAV. So once this is installed, I'll come back. Okay, so we have programming successful. So what we now want to do is connect. Now on this screen, because we've already set this up, what we're actually going to do is choose keep current settings. What I will do in a second, once I've shown you how to do the update, is I'll go back and show you what to do if you're coming at this from scratch. But basically it's the same as the earlier video. But at this point in time, we're taking it that your configuration is fine, you have your diff file, and we're just doing an update. So we're going to go to keep current settings. It says not recommended, but that is absolutely fine. Then pop into the CLI, and what you're going to do is get your diff file back. So what we're going to do is paste in our diff file to put the changes that we made back in. Now, I will just say that this is okay for INAV versions 4 and up, but if you're on an older version than that, you should really start from scratch. It's usually recommended to start from scratch anyway, and in the future I'll do a video of parts that we can take over. Because we really haven't done anything on this model and we're going up a minor version, we're okay to do this. Now at the top of this file you see this defaults no reboot. Now this is why it's okay that we can click that keep current settings, because what this will do is actually wipe all the settings anyway, so anything that we put on at that point would take no effect. So what we're going to do is just copy everything below batch start, copy, and then just paste it in the CLI and then hit enter. It will then go and put all your settings back on the flight controller. Now for you, hopefully it will just come back and reboot. So the next thing you should see is back on the setup page of INAV Configurator. But if you do get an error, I can show you how to check this out and how to fix it. But like I say, you shouldn't, because we're only getting up a minor version. Okay, so at this point, if you have the save command and it detects an error, it will tell you about it. Now I did actually see an error, but it's not surprising because these are completely different flight controllers. So we have an invalid port ID, which is absolutely fine. So let's say, for example, there was a problem with the align board yaw, maybe it was out of scope. Obviously it shouldn't be. What you can do is type get align board yaw, and it will tell you the range that you're allowed to use with this. And once you're happy, type in save and go. But as I say, we're upgrading from 5.0 to 5.1, and we've not really done any changes yet other than calibrate the accelerometer and set up the mixer. So you shouldn't have any problem whatsoever. So once your flight controller has rebooted with the save, we do actually need to go back to CLI and add one more thing. If we pop back to the release notes and scroll up, there are always release notes on the release notes, surprisingly, but there are usually things that you need to be aware of. So in this instance, there are new settings for the IMU ignore settings. Now this can actually help mitigate a problem called horizon drift. So it's well worth changing these settings. So we need to look up what we have. So the Dolphin is an aeroplane without a tail. So we're just going to copy these settings and we're going to pop back to the CLI, paste those settings in, and then hit save again. This is all you need to do if you're just doing a basic update. So skip ahead and continue setting up INAV at the next chapter. So if you're unlucky like me and you find that this page popped up when we first plugged in the USB and clicked connect and your configuration is wiped, we need to basically do what we did in the earlier video when we first set up the flight controller. But I'm not taking it out the plane. It's much better to do it outside of a plane, but that's in there pretty well. There's loads of wires, there's stuff stuck in place. I don't really want to disturb that. So what we need to do is, as if we're starting again, so we're going to choose the correct default. So this is an aeroplane without a tail, and we'll just let INAV make the correct settings for that. Now if we're on 5.1, which we are, it's automatically added the horizon drift mitigation code, so we don't need to worry about that. We also, because we've just done the presets, we have our mixer, so that's good. We still will be on the same servo outputs, so servo 3 for the left wing, servo 4 for the right wing, so there are elevons. So that's all good, but we need to do our calibration of the accelerometer. And the same rules apply. Even though it's in the plane, we need to check out where the IMU is. Now at this point, I'm not going to put all that back up on screen. So if you've done this once, you probably know whether the IMU is on the underside or the top of the main flight controller board. Like I know on this one, it's on the underside. For the first step, the IMU needs to be facing upwards. So what we're going to do is turn the whole thing upside down, and I'm going to try and get it level, but I'm going to use stuff to prop it up because it's actually more important that it is still. So that looks pretty level to me, but the important thing is that it stays still. It's more important that it's still than the angle be 100% correct. So we do our calibrate accelerometer. Of course, the first time just displays a message. We click it a second time and it will say, yep, upside down is registered. But of course the IMU is the right way up. Let's just flip it back up the other way. And we'll do that. So that's our first two done, which are nice and easy, pretty simple. Now, it's going to be pretty hard for me to demonstrate this because everything is a bit far away. But if you remember when we did the initial setup, I suggested putting the flight controller against things like boxes and all that, just to make sure that it stays still and in the right position. We obviously can't just rest our plane against a box, but we have walls. So bear with me. So there we go, the next step. I've got the motor on the ground, the wing or the bottom of the plane is against the wall. It's stable, so that will do for the next step. We can just rotate it 180 degrees. Again, it doesn't matter if it's not dead vertical. It's got to, so long as it's still, it's good. And the last two, Okay, so there we go. That was far from elegant, but it's got our accelerometer calibrated. So what we need to do is just click save and reboot to finalize those settings. So we're now back to where we were before we lost our settings. And because we've done this with a fresh install of INAV 5.1, everything is good to go. So let's continue with the tutorial. Okay, so we're now at a stage where we have INAV 5.1 installed on our flight controller. We've got all our settings and everything is good to continue. So the first thing that we're going to do is actually check for flight controller orientation. Now you can see on the flight controller in this plane that the arrow is pointing forwards, so everything should just work fine out of the box. If you have rotated the flight controller, so it makes no sense to have the arrow pointing backwards, because then all your ESC stuff will be at this end. But if you've rotated it sideways 90 degrees, where you would change it is in the configuration page. So you have your degrees here for the flight controller. Don't worry about this mag alignment, you don't need to worry about that. If you've rotated the flight controller, you would do it here. So if we've rotated it 90 degrees, I can't remember if it's clockwise or anti-clockwise, but if it's 90 degrees, you would put 90 in there. If it's the other way, you could put 270 in there or minus 90, it will accept both. But what we do is go back to the setup page, and this is where we need to validate that everything is working once you've made your changes. Of course, on the configuration page, make sure you click the save button, otherwise the changes won't take effect. But what we want to see is put the back of the plane towards us so we know where it is, and then click this reset Z-axis button. All that does is reset the 3D model on the plane. It doesn't actually change anything in firmware whatsoever. And what we're going to do is just lift up the plane, and we want to make sure that what this does matches what's on screen. So if I lift the nose up, the nose should lift up. If the nose lowers, the nose should lower. If we bank to the left, it banks left, and if we bank right, it banks right. Now you can see the physical plane here matches exactly what is happening on screen. So that is working perfectly. So that is how to rotate your flight controller in Configurator if you need to. So once we've got that set up, what we need to do is set up our receiver. So first thing that we're going to do is pop into ports, and seeing as we're here, we may as well set everything up. Now of course you made a list of which ports you used when you set it up on the flight controller, didn't you? Like I recommended you do. If not, basically check out the wires and where they go. Apologies, because the wing is on, I can't actually move this physically over that way any further, but let's get this servo out of the way. So we can see my servos are on S3 and S4, so left wing is on S3, right wing is on S4, and then written on the flight controller we have TX6, which is this front one, which is my GPS, TX2, which is the receiver. I've also got TX3 is the SmartAudio, so let's get that out of the way. TX3 is SmartAudio, this is the video, and ESC telemetry was on RX8 if your ESC supports telemetry. So they are the ports that we need to set up. So stick it on a bit of paper. You also notice that on the receiver I've made note of FPORT because that is the protocol that I'm using. Right, so back in INAV, we need to change a few things around. Now, on some flight controllers, you don't have as many UARTs as this, especially on an F411, you will have 2 UARTs. That's one of the reasons I don't recommend them. They are really not great for this sort of thing. On UART 1, you will see MSP enabled. Now, I would leave that enabled and not put anything on UART 1 as much as possible. If you run out of UARTs and have to use it, then by all means, use it. But the whole point is, if you have a problem with your USB, with MSP on UART 1, you can still connect with a serial adapter, so you don't basically kill your flight controller, you can still get to it. What I'm actually going to do is use UART 1 for ESP32 radar. That needs MSP turned on, so if I have a problem with a flight controller, I just unplug the radar and plug the serial adapter in, and I can still access the flight controller. So If there's anything that you have in your setup that actually uses MSP, then stick that on UART 1. Then you don't have to worry. Sorry, this chair is a nightmare. Right, so let's go through our list. So UART 2 is the receiver, so I will turn that off. That's all we need to set for our receiver. You don't need to do anything else. If we're using S-Bus and SmartPort, then SmartPort will be on a different UART to the receive pin or S-Bus. So you would need to set that up on a different UART. So next up, what do we have? UART 3 I've got set up for SmartAudio. So if you've got SmartAudio or IRC Tramp set up, you can set that up here. UART 6, I have my GPS, so that is a sensor, so we'll put that on there. And finally on UART 8 I have ESC telemetry, which I believe is in here. Yep, ESC output telemetry. And that's all we need to do. Don't worry about changing any of these numbers here. I see a lot of people who look at GPSs and stick it on 9600. Don't worry. A lot of the time that is the minimum speed. They will operate at faster speeds if you look in the spec, and a lot of modern GPSs do. So don't worry, leave everything as it is by default. The only reason to change it is if you have problems. So leave that as it is. So just to check everything, we have our receiver, we have SmartAudio, again, if you have it set up, or Tramp telemetry. We have our GPS and we have our ESC, again, if you have that available. So let's click save and reboot. So now that our ports are set up, what we want to do is get our receiver working. Now I'm going through this in a very specific order because we actually need some things to work to check other things out. So I'm going to turn my transmitter on. The transmitter's on. I'm on the Dolphin model. So let's go to the receiver page. Now, this is by default set up for S-Bus. We're always going to be using a serial receiver these days. If you're using S-Bus, it's already set up. That's fine. We're actually using FPORT, but if you're using Crossfire, you would obviously set this to CRSF. Same if you're using Express LRS, you set it to CRSF, but we're using FPORT. Now I'm pretty sure when I set this up, I used the standard S-Port pad. We'll find out in a sec, so let me just do a save and reboot. Alright, so if everything is good, we should have control. We do. So that's brilliant. If you're using an F4 and are having to use the inverted S-Port pad, what you need to do is actually set this to on. It's serial protocol inverted, but this is based on the default protocol. So because FPORT is inverted, we need to turn this on. Even though, yeah, as far as standard things go, S-Bus and all that is inverted compared to standard UART anyway. I don't want to, sorry, I don't want to confuse you. If you're using the inverted S-Port pad, then you need to set this on. If we're using the standard S-Port pad or FPORT pad, we need to leave this as off. So that's all good. So we can check we have all our movement. So the next step is pretty important. We need to make sure that our channels are going the correct way, but also ideally we want to set our endpoints. So because this is the INAV Fixed Wing Group model, it should already have the endpoints set up for you. So that's a bonus. But what we need to do is just double check the direction. Both gimbals, the directions are the same. So first of all, we'll check the roll. So that's over here for me on mode 2. So I'm going to roll over to the left, and we want our roll here to be going left as well, and we want it to end at 1000. Next, we're going to go to the right, which we want the bar to go to the right, and we want it to end on 2000. So that works perfect. The next one is our elevator. So this is our pitch control. So I'm going to move the stick down, and we want the number to go down to 1000. And when I push the stick up, we want the number to go up to 2000. Down is 1000, left is 1000, up is 2000, and right is 2000. And it's exactly the same on this stick here. So if we check our yaw next, in the middle we want that 1500, that's perfect. If we yaw to the left, it should go to 1000, and if we yaw to the right, it should go to 2000. And also the throttle all the way down is 1000, all the way up is 2000. As I say, on the INAV Fixed Wing Group model, that should all be set for you. If you find that any of these bars go the wrong way, this is the only time that you can reverse the channel on the transmitter. Now on OpenTX, to reverse the channel, what we're going to do is pop into our model menu, and we're going to go across to the outputs page. Now let's say our ailerons are the wrong way around. We're going to click on ailerons, go to this channel here, you can see direction is lit up, and just click. So now if we pop back into INAV, if I roll to the right, it's 1000. If I roll to the left, it's 2000. So you can see it's been reversed. It is actually wrong. So let's change that back. So left is 1000, right is 2000. So that's all you need to do if you have to reverse the channel. But as I say, you only ever reverse a channel if this screen is wrong. You don't do it to change stabilization or control surface movement at all. And we'll cover how you set that up on this plane in a bit. So now we have our receiver. That of course means that all our modes are working. So we have our ARM switch here on channel 5. We have our OSD on channel 8. We have our auto level and auto tune. We have our modes on channel 6. So we can see here that all our settings on the receiver are correct. Next, what we need to do, because we've got our receiver working, is actually copy across the stuff from the INAV Fixed Wing Group model. So let's just get our browser up and head to inavfixedwinggroup.com, and what we're going to do is go to guides, INAV Fixed Wing Group models, and we're going to go to our standard model that we installed. And if we go down, we will find our INAV CLI. And all we want to do is copy this, go back into INAV, we'll pop to the CLI, and we're just going to paste this in, hit enter. This will automatically save those settings, and what that's done is set up a couple of things for us. First thing that it's done is enabled continuous servo auto trim. So that will actually trim the servos in flight for us. We still want to get them pretty close physically, but this will actually take a lot of the work out of it for us. We've also set it so that if we have a failsafe, it will switch to the first OSD. So if you want to have GPS location on your OSD, you only need to put it on the default OSD. You don't need it on any others. If you have a failsafe, it will switch to that automatically. The other thing that it does is set up the modes for us. So that's what we're going to do next, is pop into modes. And if I hide the unused modes, you can see that we have a load already set up. But there are some missing. I mentioned that we added the port for the GPS, but at this stage we haven't actually set the GPS up. So let's do that now. We'll pop into GPS. We're going to enable GPS. I would recommend enabling Galileo satellites. It doesn't do you any harm, and if you can pick them up, it will actually improve the settings for you. Now, most GPSs these days are using U-blocks, and most of them, including this really cheap TBS GPS, will use U-block 7, which will actually improve the speed. So I would recommend trying U-block 7. If it doesn't work, it will just downgrade the protocol to U-blocks. So you're not actually going to do any harm unless your GPS doesn't use U-blocks at all. And what we will also do is set the ground assistance type. The only reason not to really set this is if you're traveling around the world all the time, so you could be anywhere. So I just set mine to European because that's where I'm flying, and this will actually increase the accuracy of the vertical. You can set up your time zone, which is in minute, and you can also choose to change for daylight savings time. So I'm going to set that to EU. My time zone is 0. If we're in the EU, it would probably be 60. Just take your time zone offset from GMT and multiply it by 60 and put the results in here. So now we can save and reboot. our GPS has the port number and it's also enabled. So what we'll do is just check that it's working. So back on the GPS page, yeah, I can see the light flashing. If your GPS light isn't flashing, so you're not getting power to it, you will need to obviously plug a battery in. But I would recommend watching a little bit later in this video when we get to the battery section, because I will show you how to do it with a bit of safety. But all we need to do is, if we have a blue light up here for GPS, and this number here, total messages, is incrementing, then everything is wired up correctly and is working perfectly. If that number's not going up, or you find that this here is red, then there is an issue with the setup of the GPS. The most common one is that the RX and TX wires are the wrong way round. So just swap the RX and TX over and see if that works. Chances are it probably will. Right, so let's get back into the modes page, and again, let's hide everything. And you can see now we have all the modes. We have stuff like return to home, auto tune, it's all there. So just to show this working, we have our arm switch. Next switch, we have our flight modes. So the first two are angle and horizon, and these change to light blue because the flight controller can do that. The next one is acro. Now there is no actual mode for acro. Acro is enabled when no other modes are selected. So this indicator down here shows when acro is working. Next up, we have cruise. Now you can see that this has turned a dark blue, and the reason for this is to indicate that it's in range. But because this is set on the desk and not flying, it can't actually get into cruise mode at the moment. So this is showing that it will work, but at the moment it can't. So light blue is for it's in and it's working. Dark blue is it's in, but we just can't proceed at the moment. The other one down is manual, which can work all the time. And then on this switch, we have return to home and position hold. Position hold in the next version of INAV will be called loiter for fixed wing. Everyone refers to it as loiter. They're the same thing, but the labeling will change just to make it a bit more easy to understand, especially for new guys when everyone is saying loiter, but the mode at the moment is called position hold. It will still work exactly the same. It does the same thing. So those are our flight modes. We have auto level and auto tune, and then finally we have our OSD. So we have OSD off, the default OSD, Alt 1, Alt 2 and Alt 3, and I'll show you how you can change these a bit later on. Now, completely up to you, but you may prefer to have the default OSD show up first. So for my personal preference, what I actually do is I have the default OSD in this first slot. The second slot I have OSD 1, so let's just drag that mode over there. The third slot I have OSD 2, and the fourth slot I actually have as OSD off. And the reason for this is actually, as I go through my OSDs, I have less and less information on there until it all goes. But the final OSD I usually use for tuning, so I have a load of stuff on there. But this is totally up to you. If you make any changes on this page, just don't forget to click the save button, otherwise it won't remember them. So where are we at the moment? First of all, we've checked our orientation of the flight controller and verified that that is all working correctly on the setup page with the 3D model. Next, we made sure that our receiver and our transmitter was set up correctly. We also set up the other ports in that step. We've set up our GPS so that we can access our navigation modes, and also we've imported the mode order from the INAV Fixed Wing Group script. So next up, let's carry on working through these tabs. So let's pop into Mixer next. Now with this plane, we shouldn't actually need to do anything. At the moment, I'm going to recommend leaving it at 50-50. This plane has got a forward swept wing. Usually forward swept wings are roll sensitive, and a plank is pitch sensitive, and a normal sort of swept back wing is usually about 50-50. So I would be tempted on a forward swept wing to actually reduce the roll a little bit to say 40 and increase the pitch to 60. But I know that with 50-50, this one actually flies fine, so just leave it as it is. We don't really need to worry about this now because we've already set it up, but our motor is on S1, we've soldered that on, and we've plugged our servos into S3 and S4. So the mixer at this stage is done. Next, let's pop into outputs. Now this is where we actually get things working. So the first thing to do is make sure that your propeller is off. We don't want a propeller on when we're working on a model on a bench. That's just asking for trouble. There are a couple of exceptions, but for this basic level, we're taking it off and making sure that it's safe. So what we're going to do is enable motor and servo outputs. That will actually make the servos and the motor live so they can be used. The next section is for our ESC protocol. Now this depends on the ESC you get. Standard should work with basically anything. And you've got a few other. So there's one shot, multi-shot, brushed, which we will not be using on these planes. They're all brushless. And then we have a few DSHOT protocols. Now for the ESC that I've put in there, I will be switching over to use DSHOT. On a fixed wing, we don't really need any more than DSHOT 150. And actually the lower the number of the DSHOT, the less chance there is of getting noise on the cable and interfering with the DSHOT commands. I've just had a look at the Atom RC website, the Dolphin manual for the PMP kit, but there's no description in there of what this ESC will actually use. So potentially you could try DSHOT. If it doesn't work, try multi-shot, then one shot, then standard. One of those should work. But unfortunately it doesn't say in the manual what it would actually use. So ideally DSHOT would be the ideal solution. Now the next box is this servo refresh rate. Now if you're using the plug and play servos or any analog servo, leave this as it is. This is to increase the frequency that the flight controller talks to the servos. Now with digital servos this should be able to be increased, but I'd only recommend doing it if the manufacturer specify it. So the servos that I'm using in this build are the PDI 1109 MG servos, and if we look at the working frequency, here we can see that it's got 300 Hertz, so I can set this to the higher level. So I'm actually going to set this to 330 Hertz because I'm sure that's what they mean, and that's good to go. The servos will actually work a bit quicker with the flight controller now. Now the number of poles is the number of magnets that you have in the motor. Most of the time this will be 14, but if you want to make sure, just count the number of magnets around the bell on your motor, and that number you'll put into there, but most of the time this will be 14. For the motor idle power, I just leave that as standard, and reversible motors we're not going to be using anyway, so leave that disabled. So what we can do now is save this, and what we can do now is plug in the battery. The reason I got you to wait is so that I can introduce this little device here. This is a smoke stopper, and the first time that we plug our power in, we really want to have one of these on. You can get different manufacturers. This is a TBS one, but you can get them from Vifly as well as a few other people, and basically this will stop you damaging your flight controller. Don't worry about that bit, it's just a power switch. So usually you just plug your battery straight into the smoke stopper and the smoke stopper into the model. Let's do that. One thing I should have mentioned is before powering on, make sure that you have an antenna on your VTX and everything that should be there is there and wired up correctly. If you don't have an antenna on your VTX, you can burn your VTX out. So make sure that that's all set up. If there are any problems, the smoke stopper should trip and you won't do any damage to the flight controller whatsoever. Okay. So if you don't get the second set of beeps, do a save and reboot. That's what I just had to do. But now everything should be working. Now you can see that I have movement, but it is wrong. Don't worry about that at the moment. And you'll also see if I arm, ooh, it did actually work. Usually it doesn't. And the reason for this is usually we don't have a GPS lock, but actually that GPS is doing a pretty good job. What I was going to suggest is the thing to do to test your motor is enable this slider here and raise the throttle. That also demonstrates something. You'll see how it cut out, and if I raise the throttle, it won't do anything. This catches me out all the time, and it is the smoke stopper. So that brilliant device that we used just to make sure that everything is okay will actually cut out if you pull too much power through it for the motors. We know everything's okay, so I can plug this back in now. So let's switch that back on, and now if I switch that, we can go full throttle and everything is working fine. But yeah, as I demonstrated, which will be easier to see on this camera, I think, if I do roll, it's actually doing pitch, and if I do pitch, it's actually doing roll. You can see there's also not a lot of movement here, and that's because we are in angle. We don't check anything with regards to control surface throws in angle. We need to do that in manual. So what I do want to do is disable this beeper, which I thought it was. It is, so it's DSHOT beeper. I'll show you how to turn that off as well. But you can see now we have more movement. It's still going the wrong way, but our servos are working. That's what we wanted to check at this stage. So what we need to do to get our control surfaces working correctly is just scroll down a bit to our servo section. Now for most of the time we just need to reverse, usually servo free, so let's do a save. It's not going to work, we need to do save and reboot. And now everything is working correctly. So what I'm going to try and demonstrate now is called a high five test, and this is just to know that the control surfaces are moving the correct direction. So if we roll to the right, we want our right elevon to come up. Basically, if you're holding this in front, that moves to the right, that should come up to high five it. That's why it's called a high five. If we roll to the left one should come up. If we pull down, both elevons should go up, and if we push forward, they should go away. If this was a plane with a rudder, the rudder should go the same direction as the stick. So we know that that's working. The other thing we can check is the stabilization is working the correct directions. So if we go back into angle, again, just by moving them, they should move the same direction. So roll to the right comes up, the left goes down. Left is obviously the opposite, that goes up, that goes down. Pulling down on the stick, they both go up. Pushing on the stick, they both go down. So that's all good. And the next thing that we want to check is the stabilization is working. So if we roll to the right, we want this one on the right to come up, the one on the left to go down. And the same, if we roll to the left, the one on the left should come up, which it's hard to see, but it is, and that one should go down. If we point the nose down, let's try and get, this is very hard to get on camera, but they should both come up, and if we point the nose up, they should both go down, which I think is a bit easier for you to see. There's not a lot of movement there at the minute. But if it's doing that, our control surfaces are correct and our stabilization is correct. So the first thing that I'm going to do is disable DSHOT beeper so we don't keep getting that. Pop in the CLI and undo get DSHOT. And we got DSHOT beeper enabled. Let's copy that and set DSHOT beeper enabled equals off. Save. This will make things a lot less annoying. Okay, so now we perfect. So let's get back to where we were to catch up. I should have mentioned, if you find that this works but when you arm it doesn't. Don't worry about it. If your receiver is set up correctly so that the throttle works, and on the modes you have an arm, then everything should be fine. There's going to be something like the GPS that is stopping it from actually arming the motor. So don't worry too much, it will work in the right situation. We're just lucky that I'm getting, how many satellites have I got? So I've got 10 satellites indoors, which is pretty good actually. So that's why I'm able to arm. But if you can't, chances are if that's below 6, or you don't have a 3D fix, it definitely will not arm. So that's probably what it is. So don't worry too much, but let's get back to the outputs page and just go over what we've got done. So our motor is set up, our servo is set up, and our servos are going the correct direction. If you find that they are still not right, you can just change these reverses just to try and get them right. If they're still not right, but only on one axis, then what you should do is reverse it so that the pitch and roll is correct. Then whichever is wrong, pop back in the mixer. So for example, a roll is correct but our pitch isn't. All you would do is reverse the pitch. So for example, I would put -50 and -50, but again, you really shouldn't need to do that. Just changing S3 to reversed should be all you need to do. So that's all set up perfectly. But now what we're going to do is just check our throws. If you remember earlier in the build, I did a basic setup, but I said I was going to wait until we're in INAV just to make sure that everything is good. So the first thing to do is put it into manual mode. And next what we're going to do is see how much throw we have. So in INAV, it's actually looking like there's less throw than there was on the servo tester. There are a couple of things we can do. Ideally, we adjust everything so that it's correct physically. But if I know that you can get more throws out of those servos, the first thing I might try is changing these to 120. Again, we're aiming for around about 12 to 14 millimeters of pitch and roll. So let me just save that. And that looks a bit better. I'm not going to be able to do this on camera because the wings are actually connected to the plane, so I will not be able to show you this in the camera. But what I will do is put the gauge on and then we can check it out. So let me do pitch first. It's still a little bit down. So what I will do is adjust it physically. So I'm getting around about 6 millimeters of down and about 13 millimeters of up. So we're getting more up and down, which is fine as far as differential goes. But I'm going to actually change these to get a bit more throw. So let's power off and might as well disconnect the USB. And what I will actually do is set these back to 100. And let's disconnect. So if you remember, there are a couple of things that we can do. To get more throw, we could lower it on the outside here, or we could raise it on the inside here. So I'm just going to raise it up to the second hole on the servo. And I think that will probably do it. And there was actually quite a lot of differential there, so I'm going to move this control one towards the front a little bit more. Again, this is a bit of experimentation, but it's better to get this physical stuff right. And of course, remember that when we get everything in, we need to make sure that this here is nice and flush with the servo centered. So let me just nip that nut back up. I'm only doing the one side to begin with. And once we've got this side right, we can just mirror it on the other side. Okay, so this is the side that we adjusted. So we're going to have a lot more throw on this side than we are on the other side. And of course, I'm still in manual. So let me get this tester on and let's see where we're at. That's about 12 mil of up. And that is about, actually it's about 11 mil each way. So that is pretty good. And the rest of it we can update with setting the rate in configurator. So let me just do a save. That's closer to 14 mil, so I reckon 110 will be about good. That's about 13, and that's about 12. So that there is actually perfect. That sticks up a little bit more than the body, so if that was taped to the body, that's pretty good. So what I'm going to do quickly is just power off and mirror the setup on the other side. So there we go. I'm happy with this setup now. I've got this on the second hole out from the servo. This is on the top hole. Everything is nipped up nice and tight. You can see there is absolutely no slop in this whatsoever. So that is good to go. We have our throws set up. So the sun's actually getting low in the sky, so it's making the video look a bit crap, but I apologize for that. Anyway, let's plug back in and continue. Okay, so we have our throws that of course we set in manual. So we have about, it looks massive there, but it's been measured. That's about 12-13 mil of up, about 11-12 mil of down, and it is the same on the roll. So now if I switch back to a stabilized mode, this will be a lot more obvious. So nose up, nose down. You can see the surfaces moving the correct direction a lot. It's a lot more obvious now we have a bit more throw. But if we compare acro to manual, so you can see there is still quite a big difference. There are two components to how much throws your control surfaces will have. There's the rates and the feed forward. And the rates is basically how fast the plane will move on a certain axis. So you have a roll rate, pitch rate and a yaw rate, and the feed forward is calculated based on the rate to get that movement for you. So if we jump into PID tuning, which is a little bit more advanced than beginner stuff, you can see these are the defaults for an aeroplane without a tail. You may have heard of PIDs. If you haven't, then I'll put a link up to a video I did with Mark Hoffman, which is a complete series explaining about the tuning side of things. But what we're interested in is feed forward. The rates that I mentioned are on the rates page, and these are set as pretty sedate rates so that they cater for everything. So to give us a bit more of a fighting chance on the maiden, what we're going to do is actually set the feed forward based on what we have here. So we'll do it on each axis. So the top one is roll. So what we're going to do is switch into manual and have the other mode ready on acro. So we're going to move over full roll to the right and then switch to acro. And that's not too bad. I know it's difficult to see. Again, the size of a plane, I can't really get it under the camera. But what we're looking for is about 80% of the movement. So if manual is 100%, we want 80%, and the same with the pitch. So full pitch back and then switch to acro. Now on pitch, it's a lot different. So I'm going to bump that up to 90 and we're going to hit save and we'll try it again.
Manual, acro, manual, manual, acro, manual, acro.
Actually, roll could come back down. Let's go 55 and let's go up to 95 on the pitch.
Cruise, acro, manual, acro, manual,
right, that's better
acro,
for pitch.
Manual, acro, manual.
Roll was fine at 50. So that's just going to give us a little bit more of a fighting chance when we maiden the plane, especially if you are wanting to maiden with auto launch and don't have anyone with you. This is really ropey video, but at least it will demonstrate it correctly. But yeah, you can see here the control surface, that should be flush. So I do need to adjust this out a couple of turns. But what I wanted to demonstrate was, let's get that. That will be the throw in manual, and the throw in acro is about 80 to 90% of the throw in manual. And you want the same, this is the roll, it's about the same on the roll, that same difference. That's what you want to get set up with the feed forward. And if you do that, it will give the stabilized modes a better chance to get it right. The other thing I should mention is once you're happy with the servo setup, what we're going to do is hot glue them in. So yeah, just make sure that they're firmly seated and apply some hot glue. Take them out, apply some hot glue around the sides. I wouldn't worry about the bottom too much, just put it around the sides and then firmly push it in and wet your finger and then just sort of dab it around the edge just to smooth it off. I mean, that bit does hurt a little bit, but it makes the plane look better. So now that the feed forward has been adjusted, our control surfaces are complete. So let's get back and continue on with our list. What I'm going to do is just power off for the minute because we don't need the battery power on there. Outputs we've done, ports we've done, configuration, let's have a look in here. Now all this should be set correctly by default. In some instances the barometer may be incorrect. There's two barometers, the SPL06 and what's the other one? I think it's a DPS 310, which have the same hardware ID, so INAV can't tell the difference. If you have either of those barometers, check the Maytech website, because one of them is made of a nylon, the other one is made of metal. That's the only real way to know the difference. We don't use magnetometer, and at this early stage we won't be setting up rangefinders or pitot tubes or anything like that. The next thing is this 800 kilohertz for I2C. On this it should absolutely handle it fine, so I'm going to change that. We mentioned the yaw degrees if you've changed the alignment of the flight controller, so that's all covered. Now these features are to turn things on and off. It might sound obvious, but yeah. So for a lot of cases, unless you've added something different, the defaults are absolutely fine. So with fixed wing, we always want stop motors on low throttle to be on. This is not the same as motor braking. This is just that when you put the throttle down, it will not spin the motors. With a quad, as soon as you arm, motors spin. We don't want that on fixed wing. We want it so that low throttle, the motor is cut. Not just for a safety point of view, but if we're landing with the motor still running, we're just going to kill the prop, maybe rip the motor off. So that's another reason why we have that on. The CPU-based serial ports are something that we only really see on F4 flight controllers, especially things like the F411 where they simply don't have enough UARTs, they only have 2. But also on the F405 they can be used for SmartPort telemetry because the F4 series don't have inverters on the flight controller, so they can invert it using soft serial. But you shouldn't ever use soft serial for anything critical like receiver or GPS. Right, GPS for navigation and telemetry, we've enabled that. That is the same button as on the GPS page, so if you turn it on there, it turns it on here too, so don't worry about that. Telemetry output is on by default. That's to actually send information back to the radio. So if we're using things like the INAV Lua script, which is a bit more advanced, I'll cover that in another video, we've got all the data there for that. Reversible motors, again, we don't really want to use that. That was on the outputs page too. Analog RSSI, again, most modern receivers don't use this, so don't worry about it. If you want to use LEDs, you will need to turn the multicolor LED support on. Again, this is something that I can get into in a future video. I do have an old video on setting this up, so again, I'll link to it. OLED screen is a little display screen, which is only working when you're disarmed, just shows you the status of things. To be honest, I've not really bothered with them. I get all the information I need in the goggles. Black box flight data recorder. If you want to record your black box to an SD card, you need to turn this on. Be careful with some SD cards. There are issues and it can affect same cards of same makes, so it's quite a random thing where if you can't connect to INAV or there's a lot of slowdown, it will most likely be because of the SD card. If you unplug the SD card, it will work fine. Okay, so there's an SD card in there. I don't know if it's going to work or not. We need to reboot, so let's disconnect.
Telemetry lost.
See, this may highlight the
Telemetry
problem.
recovered.
You notice how this is taking absolutely forever. That is because of the SD card. And I believe if you do just leave it for a while, and it can be upwards of 10 minutes, it should come back and start working. But yeah, this is the issue that people have. So I'm going to take this out for the minute. And again, it's something that I maybe should cover in a different video. Let's get back to it. There we go. Pops up straight away. So let's go back to the configuration page. So yeah, black box is very useful, but there are some SD cards that are problematic. Enable motor and servo output. This is the same as we set up on the outputs page. OSD we want enabled. I believe if you're using HD, you still use the OSD tab to set everything up. Permanently enable air mode. Just leave that on with fixed wing. What it will do is when you're at low throttle, it will keep the stabilization active for you. Permanently enable launch mode is really a personal preference. My preference is to have launch mode on a switch, which if you go through the INAV Fixed Wing Group documentation on the standard model which we installed, how to set that up on a switch is actually covered in there. But yeah, that's my preference. Profile selection with TX sticks, that is so that you can change this profile here.
Inactivity alarm.
With your transmitter. Again, it's a bit more advanced and it's not really something we need to worry about. Throttle voltage compensation will actually try to increase the amount of throttle at certain throttle levels so that it matches no matter what the battery is at. So if you're say at 50% throttle with a fully charged battery, without that turned on, it will give you more power than if you're at say 50% throttle with a 50% battery. Just the voltage has got lower, so it's spinning the motor less. So this actually compensates for that. The automatic battery profile selection, if we use different batteries, we can actually change these battery settings here. So if we set up for 3 cells and then set up another one for 4 cells, it can detect whether the 3 cell or 4 cell battery is plugged in, so it can automatically change for you. Anything you see in configurator with this sort of orangey color is related to the battery profile. There will also be settings, not on this page, but on other pages, in this sort of baby blue color, and they are related to the control profile. And finally, continuously trim servos on fixed wing. That is turned on with the CLI that we used from the INAV Fixed Wing Group. So let's pop up back here. So this is our voltage and current sensor. Now these are the settings that are default from Maytec. When you select your target, it will automatically add settings for you. It's well worth checking on the Maytec website though, because for example the H743 that I'm using here, it's the same target for multiple boards, so there could be a different setting for your particular board. So let's check that out while we're here. So I am using the H743 Wing version 3, and let's see what it says for our current sensor scale. There's nothing up here, so it should be the same for both flight controllers. So battery voltage sensor is 1100, so that is correct. And current sensor scale, where are you? Current sensor scale 150 in INAV. So this one actually needs to change. So it was different on a different flight controller. So we'll set that to 150. And that will give us a decent ballpark. The Maytec standard settings are usually pretty good, but you can actually check your voltage with a multimeter to fine tune it, and you can also calibrate the current sensor using a tool that I have on my website, but that does involve the propeller being on with you throttling up the motor, so I would probably leave it as standard for the time being. The next section is our battery, so you can leave it at 0 for automatic, but if you did want to use the profile switching, you actually need to tell it how many cells on this profile. So I'm going to use a 4 cell here, and I'm going to use 4000. These settings here are absolutely fine for LiPos. You will want to change the minimum cell voltage for lithium ion. The warning voltage I'd probably put around 3 volts or 2.9 volts. Warning capacity remaining, I'm going to set that up to maybe 40% and 30% for critical. That should be a nice sort of safe buffer. The next settings are for if we're using a SmartAudio or IRC Tramp setup with our VTX. So this will automatically switch power and bands. So I'm going to be using Fat Shark 4 and I'm going to use power level 4. On SmartAudio, usually it's only power levels 1 to 4. On IRC Tramp, you get power level 5. Now, low power when disarmed, I'm going to turn to until first arm. So when you're disarmed, it will be in a low power mode, so 25 milliwatt typically. And when you arm, it will go up to power level 4. So that's everything we want to change on this page. So let's do a save and reboot. Right, next up, let's sort out our failsafe. So this is what happens if we do lose signal between the radio and the plane. And of course, we're using a navigation firmware. We have a GPS, so we want it to return to home. So all we need to do is change this to return to home and click save and reboot. Next up, what we're going to do is make sure that the failsafe will work. Now, I mentioned in the radio setup videos that if you're using FrSky, you should set the failsafe mode to hold or no pulses. And if you're using Crossfire, you should set the failsafe mode to cut. If that's set up, we should be absolutely fine, but we are going to check that it works. So this parachute up the top here is indicating a failsafe. At the moment it's grey, so we're connected, there's no failsafe. But what we're going to do is turn off the transmitter, no matter how much it argues about it. So we'll turn that off. And what should happen is the parachute should turn red, which it has done. If it's done that, then it's in failsafe mode. It knows that it's lost connection. And now what we'll do, we'll turn that back on.
This isn't flying, this is falling with style.
Switch warning. INAV Fixed Wing Group.
And the parachute should go back to grey when the link is re-established, so we can get control back. So if that works, then we know that our failsafe will be detected correctly. So if it doesn't turn red, you need to check your failsafe modes and make sure that that's all fine. Again, it's either FrSky is hold or no pulses, Crossfire use cut. Right, PID tuning we've already taken a look at. Advanced tuning. Now there are a couple of settings that we can talk about in here. First settings are if you want to use auto launch. The settings in 5.1 have been tweaked slightly by Mark Hoffman, so they should be a bit better now. But there are certain things that we will need to fine tune for our specific sort of style with the auto launch or for the actual plane itself. So the climb angle has been set to 25 degrees from 18 degrees. For something like the Dolphin, that will be absolutely fine. It only needs to be lowered for things like a mini Talon where you want to get airspeed up more than you want to gain altitude. There is a launch timeout of 5 seconds. Now this is fairly short. I usually go for about 10 seconds. And maximum altitude of 50 meters, which I usually go a bit higher because I fly with other people. I want to be out their way. So I go up to 100 meters. Now you can see on here I have things like meters and seconds, whereas your display may show something a bit different. The reason for this is I've changed the configurator options to metric. So it just makes the units a bit easier to understand and read. If I switch back to the none, which is the default units when you first install configurator, this will be in centimeters, this will be in milliseconds. It's a bit more of a pain. So I would recommend, you can use imperial or metric, or OSD will actually use what you're using on your flight controller's OSD. So your personal choice of what you want to use. So there's another couple of settings. That there is a minimum launch time, which basically means once it's launched, you won't be able to control it with the sticks for this time. So it's worth setting this to something like 2 seconds to give the launch time to work. It also means you won't be bumping the sticks accidentally. The other thing that we have is a maximum throwing angle. You shouldn't need to change this. 75 degrees, even if you're doing an overhead launch, which I don't really recommend. 75 degrees is fine because you're actually launching sort of like that, which is more like 45 to 50 degrees. So the 75 degrees is absolutely fine. The two bits in yellow, which you can tell are linked to the battery profile, are the launch throttle, which is how fast the motor spins once launch has been detected, and the idle throttle, which is basically when you first set launch, it will spin the motor. This gives you a little bit of assistance. But how to work these values out? Now, I do have a video on auto launch, which I'll get into link to, and you can do this by holding it and powering up, but again, there are sort of different ways of doing it. So on my website, I do have a tool to estimate the launch throttle. So what we're going to do is set our propeller size. So I'm going to be using, I think, a 6x5 with this. I might have to go down to 5x5. The kVA of the motor, which on mine is a 2050. It has one motor. I'm using 4S. And then the weight of the model. All right, so that's giving me about 810 grams. So let's just go 825 just in case, because there's propeller to go on there and other little bits and pieces. Let's do 825 as an example. Obviously you'll weigh your plane because it will be different, and then set the country that you're in, and this will give you an average temperature and altitude. Now I know where I fly, the altitude mean sea level is actually lower than that, so I'm going to go down to 50. And I know my ambient temperature is going to be warmer than that. These are year-round ambients. So I'm going to set this to, I don't know, let's go 15. And then click calculate. Now what this will do is give you some ideas for your launch throttle. So it's given me 1250 for the idle throttle, which is just ticking over basically, but it will give you 88 grams of thrust, which is about 10% of the model weight. And we have 1750, which should give around about 840 grams of thrust with that propeller in those conditions, which if you see it's going up in 10 microseconds. That weight there is just over the 825, so it's just going over to the next one. If you want, you can increase it a bit just to give you a bit more leeway. So what I will probably do is set 1250 and I'm going to go to 1800. So 1250, and I'm just going to bump that up to 1800. The other thing that I like to do on mine is have an idle delay. And what this does is when you have everything set up, so watch the auto launch video, it goes through the sequence of how you get it ready to throw. But basically it gives me 5 seconds from when I raise the throttle, which you raise to the level for after auto launch. It gives me 5 seconds after that until the idle throttle starts. This is a nice bit of time to get yourself composed before you actually throw the plane. Those settings I'm quite happy with for auto launch. Cruise throttle will depend on the plane, the motor setup, everything like that. So 1400 may be a decent starting point, but you may want to adjust that once you've actually flown it and got used to it. Cruise throttle is basically the normal throttle level for navigation mode. So that's cruise, return to home, loiter. They'll all sort of base on this 40% in this case throttle. If you're climbing or descending, it will adjust the throttle to cope with that. This setting I quite like, allow manual throttle increase. What that will do is if you're cruising at this 40%, but either it's too slow, the wind's picked up, you can manually increase the throttle above that cruise throttle. You can't lower any lower than the 40%. At this beginner stage, you don't really need to worry about them. They're absolutely fine for getting started with INAV. The only ones that you may want to look at is loiter radius, which this is set to 75 meters, so 150 meter in the sky. This could probably turn a bit quicker than that. The other one is your loiter direction. I just like setting it to yaw. Basically, when you're doing a loiter, it will default to going right. If you want it to go left, you just hit the yaw stick left and it will start loitering to the left. It's just a nice little setting. So that's those settings. Below, I wouldn't worry about any of these at this stage, but we have return to home settings. Again, I have a separate video on return to home. I would check that out for a lot more detail, especially with how these modes work, because return to home you really want to set to your current location. But at least as a default, what that will do is the altitude you have here. So if I set this to 100 meters, it will, if you're below 100 meters, it will climb up to it. If you're above 100 meters, it will stay at the altitude it's at. The other one to set is this return to home altitude. What that sets is when you arrive at home, you will start loitering. If that's on 0, it will stay at this the altitude that you're currently at. So that could be 100 meters, or it could be, if you're above 100 meters, whatever you're at. I like to set this to 50 meters, which I know will clear the local trees in my area, maybe 75. But it will actually lower the altitude. So I know that we're not allowed to fly that high, but say you were at 1,000 meters high and you do return to home. If this is at 0, you'll stay at 1,000 meters. With this set to 75, it will gradually come down until it gets to 75 meters, and it will start loitering at that 75 meters. So it's a much nicer setting to have. Climb before return to home. Again, this is a personal and an environmental issue. I personally like it on so that it will climb before it turns. But I also use a 2-stage, which again is covered in the other return to home video. But I go over all the reasons for and against all these settings in that. The only other thing that I'll mention is land after return to home. On a fixed wing, I would leave this on failsafe only. So if you lose control with your radio and can't get it back, once it gets to home, it will loiter down and keep going until basically it thinks it's at ground level, and then will, just above, will cut power and loiter down onto the ground. You do need quite a big area for this to be successful without obstacles in it. But the other option is you just leave it loitering until it runs out of battery. So it's it's up to you what you want to do. The one thing I would never do is set it to always, because the land, as you may have gathered from that, is more of a controlled crash. It's not really a, I know which direction you took off in, I know where your runway is, I'm going to land. It's just loitering down and losing altitude. So in a failsafe situation, it could be handy. For example, if you've got a plane with a huge battery in it, say a 10 amp hour battery, and you have a problem with your radio 5 minutes after you've launched, it could be flying around in circles for 2 hours above your head. And you just have to sit there and watch it if you have this on never. Whereas failsafe only, at least it will start coming down. So those are the settings on this page that it's worth taking a look at. And let's just click save and reboot to get those settings finalized. Right, the programming page I'm gonna just ignore at the moment. Where you're beginners, there are some cool things you can do with it. So if you're interested, I have videos on automatically changing your VTX power. I also have, actually this is probably one that might be good for the beginners. It's if you accidentally disarm in flight, it's how you can just rearm straight away with the switch. Or if you have auto launch, you do need to cancel it before you take control back. But this is quite handy. So we just need 2 programming features. So what we need is a greater than, and we're going to use a flight parameter, and we're going to use 3D speed. and we're going to set this to, this is in centimeters per second. So if we're flying above 20 miles an hour, for example, so 20 mph to cms. All right, so 20 miles an hour is 800. So let's go 15. It's going to be above walking and running speed, 670. So let's go in the middle. Let's do 700. So if we're above 700 centimeters per second, which is going to be about 17 miles an hour, something like that, which you're definitely not going to be having the model on the ground doing that speed. What we can then do is, where are we? Override arming safety. And we want to set this to only when logic condition 0 is active. So if we click save, you'll notice it's doing nothing at the moment. But as soon as we're flying, if we're above that 17 miles an hour, or specifically 700 centimeters per second, if we accidentally disarm, we can rearm. Don't be tempted to lower this value to something stupid. If you accidentally disarm and you're only doing sort of 10 miles an hour on your way into landing, then it's not going to do any damage anyway. This is only for if you're actually flying at a decent speed. If you accidentally disarm, you can just rearm straight away, and that will basically get you out of sticky situations. But yeah, don't be tempted to have this on all the time. It's really dangerous, and actually you could have features not work because of it. For example, if you arm without having a GPS lock, you won't have a home position. Return to home won't work. If you have a failsafe, your model will just fly away. So don't be tempted to tweak this. This is a pretty safe way of doing it, and it gives you a little bit of safety in flight. But yeah, the programming tab is useful for things like this. But again, I won't go into any more detail. It's something that's a bit more advanced. Receiver and modes we've covered. Adjustments, again, is something more advanced. I'm not really going to go into that at the moment. Magnetometer, we are using fixed wing, so we don't have one. And if you get a GPS with a magnetometer, I would recommend just don't wire the magnetometer up at all. If you do, in configuration, set it to none so that it's not working. It can actually make navigation, less efficient in INAV to have a magnetometer. Mission control, again, I'm not going to go into this because it's more advanced. This is where you can set up waypoint missions. I'll come back to OSD in a second. LED strip is where you would set up LED lights. Again, I linked to my video, I'll put it in the description, so that how to set this up really hasn't changed. And the last three, again, I'm going to skip, not really needed at this stage. And CLI is the command line interface where we can directly talk to the flight controller and change parameters, and more importantly, get the diff all so we have a backup of our configuration, which I will be doing right after we go to the last thing, which is the OSD. And this is our OSD. So I've actually got the, there we go, the FPV camera hooked up so we can actually see what settings we have on there. So an OSD is actually quite a personal thing. You can set this up however you want. To change what you have on there, you can just drag them about the screen to put them wherever you like, and choose what you want to display. As I mentioned, we have alternate layouts, so there's nothing on layouts 1 to 3, and we have the default layout. Now, as I did mention, if you have a failsafe, it will automatically switch to the default layout. So what I can do is demonstrate that. So if I switch, if I switch OSD to Alt 1 and then power off the transmitter, when the failsafe kicks in, you'll see that it's gone to the default OSD. I've not actually touched anything. It's going to have, I can't actually read what it says on there. One sec. So yeah, it's got failsafe, no RC link. And once we get our system back,
This isn't flying, this is falling with style.
INAV Fixed Wing Group.
there we go, it's changed back to the other OSD. So I'll adjust that so we're in the correct OSD. Right, now you will notice that some of the characters look a bit strange. The reason for this is we haven't updated the font yet. Now this is something that you should do every time you at least change major version of INAV. So if you go from INAV 5 point anything to INAV 6, you should update the font because there's likely changes. If you come from a different firmware completely, like Betaflight or Arduplane, definitely update the font. And if it's a new flight controller, also update the font. So what we're going to do is open up Font Manager, and you'll see there's different types of font. So we have bold, which if you click it, you can see a preview here. Clarity. You can basically go through and pick which one you like the look of the best. Personally, I actually like default. I'm quite weird. A lot of people don't like it. I like it because it's quite small, but it's still readable. So I usually just use default. So once you get there, just click Upload Font, and that will save it on the flight controller. It's actually stored on the OSD chip, not on INAV. So INAV doesn't know which font you're using. So once that comes back, you will see our actual elements are now displaying correctly. So if we go back into the OSD page, we can actually start moving things about. Now, on this monitor, you can see things that are disappearing off the top. So if I move those down a bit, we'll actually get a bit more information. So my personal preference, and again, this is completely up to you, is I like seeing cell voltage because then I don't have to do calculations in my head. So I always use cell voltage, which is the pack voltage divided by the number of cells, and that gives you a nice idea. And I use sag compensated as well. I use the amps, so you can see how many amps you're using at the moment. I usually base landing, that sort of thing, on voltage. If you're flying with a LiPo, then you want to be landing at about 3.6 volts per cell. I wouldn't go any further than that. If you're on a lithium ion, you want to be at 3 volts per cell when you're thinking about landing. Once you get below 2.9, 2.8 volts per cell, the voltage just falls off. These cells are supposed to go down to 2.5 volts, but you'll get there very quickly. So once you get to 3 volts per cell, start thinking about landing. With regards to what you put on your OSD, as I've mentioned, it's completely personal preference. So I'm just going through what I use. So I use UK units. I like crosshair 6. You can have the crosshair, artificial horizons, sidebars. Once you have that, you can choose what these do. So left hand side I usually use for speed, right hand side for altitude, and I believe that's actually what they use in aviation. Just basically go through and pick what you want. As I mentioned, if you're using the satellite coordinates, you can put these on the default if you want. So you can have the traditional longitude and latitude, or you could use plus code, which you just look up in Google, which is what I tend to do these days. So I just have my plus code, and you can choose how many digits you show for the plus code. Is there anything else that's useful? So we have our ground speed, which we can put here. We've got our altitude on this side. The variometer, the numeric variometer is actually pretty useful too. So if you're doing an auto level, once this settles around 0, then you know that that's a nice sort of setting. Again, this screen I usually overload with all the information I want. We're going craft name. So I put lots on here because I don't usually fly with it. I switch to an alternate, and I'll show you a quick way soon of how you can get all this information on the alternate so that you don't need to repeat everything. So I'm just going to just put a load of stuff on there. So home distance and home arrow I want. Right, so direction to home. Actually, that usually goes there. That goes there. Where's distance? Distance to home. If these things overlap, you might have to just move them and put them back. Don't worry about it, it's fine. But yeah, I can't actually remember what I usually have. I do have 3D speed as well. So that will give us a nice start. But obviously set this how you want it, put whatever you want information wise up there. The one thing I would recommend always having is system messages. If you have a problem arming, this will tell you what it is. So let's just do a save. And I've actually noticed something else we need to change for FPORT as well. So that's related to the RSSI. At the moment we obviously have full signal, but it's only showing 49, which is obviously not the case. We're getting 100% here, so we can change the scale. But first, let's continue with the OSD. So to repeat this on another page, unfortunately there's not just a button to copy the layout, but we can do it with my tool. So what I'm going to do is just type OSD underscore layout, and that will return the current layout for our OSDs. Now our default OSD is OSD 0. So what I'm going to do, actually I can just copy all of it. So copy to clipboard. And what we're going to do is go to my website again, and there is an INAV OSD switcher tool. So this is quite easy to use. What I'm going to do is just paste in the CLI code, and I'm saying I want to copy the default layout to alternative layout 1 and update OSD. This new code here has copied all that across, so let's do a copy to clipboard, and what I'll do now is paste that in, and this will update the firmware. So when this finishes, we will have the exact same layout on OSD, on the default OSD and OSD 1. At that point you can start taking things off of OSD 1 if this is the way you want to do things, and then you could repeat this process but basing on all OSD 1 and copying to all OSD 2, and again removing what parts you don't want as you're gradually getting rid of OSD elements. So let's pop to OSD, and you can see this is our default layout, alternate layout 1. We didn't have anything on it before, but now it's exactly the same as the default OSD. So we can actually get rid of some things just to make it look a bit nicer. So let's go to throttle position. As I mentioned, we don't need the GPS coordinates on anything other than default because it will switch to default in a failsafe. I do generally try to keep things in the same position just so that you don't have to remember where things have moved. So let's just get rid of the sidebars, get rid of that, and let's put that up there. It's a similar place, and let's get rid of that. Okay, so this has got the similar information on but a bit less, and it's in the same sort of positions. Then if we do a save, back to CLI, OSD underscore layout, copy to clipboard. You can actually just do a full diff and it will still work. So let's get rid of that and paste in the current one. Copy alt layout 1 to alt layout 2, update OSD, copy the clipboard and paste and go. And again, when this comes back, we will have what we've just done on alt layout 1 on alt layout 2, which is currently blank as well. And I'll show you that it's blank by going to alt layout 3 in a sec. Okay, so we're on our OSD, so let me show you the progression so far. So we have our default layout. If I switch this, this is alt layout 1, and if I switch it again, it will show the same thing, which is alt layout 2. But now we can get rid of even more stuff just to clear it up even more. So let's get rid of the AHI, the crosshairs. Let's put our speed somewhere different. Put our altitude somewhere different. And let's get rid of the digital or the numeric vario. System messages don't show up unless you've actually got something to show. So now you can see how our OSD progresses from full information, a little bit less, and less again. And there's alt layout 3, which has nothing on it whatsoever. So that's the OSD. Again, really, you can just play with this and change what you want. If you're using DJI or HD0, HD up here is for HD0, not for DJI. So don't let that confuse you. For DJI, I believe you put it on auto, but it could be PAL or NTC. I don't really know. I don't use it. With DJI, there is this option down here to hide elements that you can't use with DJI. So you can see that the list has got a lot smaller, and basically these you can put on there and position. But again, I don't really know much about DJI. I don't use it. I know that in a future release, this actually should be automatic. If you select HD0 as your peripheral, the HD0 stuff will appear, and if you select DJI as your peripheral, only the DJI stuff should be there. So it will be a bit simpler for you guys in the future. I don't really know how that works with the walk snail stuff. I'd imagine it's the same as HD0 actually, because it's canvas mode, so it should be similar to that. The only other thing that I will mention while we're here is the alarms. These will start flashing elements on screen. If you find that something just disappears, it's because the blink isn't working, and it could be because you have a mismatch of modes. So when you set up your FPV camera, ideally you want to match it here. So if that's set to PAL, I will set this to PAL. There are a couple of exceptions with some Maytech flight controllers. So if you're using, I think it was the F411 WSE, you want to keep that on auto. But usually it's better to actually set the specific type of OSD you're using. There's not really much more on here. This is really just for playing about with stuff. Once you get down to global variables, underneath that there's not really anything at this beginner stage you need to worry about. Global variables are used with the INAV programming. The adjustment values are used with this adjustments here, and PIG controller outputs are again for tuning. These switch indicators are matched up to the switch indicators here. So as an example, I can put one on screen here. So we can say what that is. So I don't know, put tune, I guess. So it's the auto tune switch, which I think is on channel 7. I can't actually remember. So if we save that, go back to the full OSD.
Auto level. Auto tune.
It will actually move the switch.
Auto level. Auto tune.
So that's all we really need to know for the OSD. The last thing I will just mention briefly is for the FrSky FPORT RSSI. So if we go into here and type get RSSI, there will be an RSSI max. So I'm going to copy that, and I'm going to boot set RSSI max equals 50, because the maximum with this scale will be 50%. And once that's done, we can click save, and now the RSSI on the OSD will actually be correct and match up to what is on screen here. It's only 3 digits, that's why we see 99. So, but you can see here I'm at 100% RSSI. That's on 99, but let's see if I can get into range. So RSSI on my screen is R92. It's 92 on here, and it's 91 there, so it's close enough. Let's get it down there. 80, 84, 82. So on the OSD, for some reason, even though it's correct here, it's one less on the OSD, but again, I wouldn't worry too much about that. It's going to be close enough. At this stage, we are pretty much ready to go. Even though we've gone through everything once, what I would do is recommend going through my pre-maiden checklist. So if I close configurator and again look on my website, if we go under tutorials and testing, flight controller therapy, there is an INAV pre-maiden checklist. Now this was written, I think with INAV 3.0, but basically the checks are the same. So just go down through this checklist, and it's quite brief on here. There is an accompanying video, but just go down through this checklist and make sure that everything is working, and that will give you the best chance of getting a successful maiden, which is going to be the next video. So at this point, I've just got some final gluing stuff in, and obviously we need to check that the that's a good point actually. We've not checked the VTX, have we? Let's see if our SmartAudio is working. Let's connect. Let's go to OSD, and we'll go to Alt 1 because I believe that's the OSD we're currently on, and what we're looking for is, there should be a VTX section. Let's go VTX bands, channel and level. There's two different elements just to show them next to each other. So basically the first is the channel, so F4 in this case, and then after the semicolon is the power. The one with the little VTX and power is just showing the power. So if I arming, it should jump up to power level 4, which it has done. So if I looked on the screen on here, which I can't see because I've taped it down, it should be on power level 4. Let's have a look. Yeah, F4, power level 4. So SmartAudio is working. And if I disarm, it will stay at power level 4 until we power cycle. At which point, oh, of course, USB is plugged in, isn't it? Let's do a proper power cycle.
Telemetry lost. Telemetry recovered.
And we're back at power level 1. Power level 1 on the VTX. So yeah, the SmartAudio is working. So I just noticed that on the bottom of my checklist. So yeah, go through this checklist again. I'll put a link on the video description, but there's quite a few useful tools on my website. So it's in tutorials and testing, and there's some other useful tools in the useful tools section. But yeah, getting back to the end of the video, because this is, well, it's 2 hours and 42 minutes on the recording. So yeah, the next video will be the maiden flight. Now, I have been trying to get these videos out every 2 weeks, but due to weather, I can't guarantee that the next one will be. So my plans for this plane is just to finish up a few things. So I did try gluing this camera in, but it's just not sticking to the carbon. So I do need to get that glued in properly. We will get the level set up properly. And of course, sorting out CG with the right battery, getting that dead on. I will need to make an extension for this power cable, so I will record that when I do it, and that will be either a part of the maiden video or a separate video. This bit of foam here will be coming out because I can't even fit my battery under it. But yeah, other than that, we're basically there. Of course, hot glue your servos in. I will find the right antenna because this is left-hand polarized and all my stuff is right-hand polarized. I just couldn't find the right antenna, but I will get that on there. But yeah, I will be going through the pre-maiden checklist myself just to make sure that I didn't miss anything, but everything should be good to go. Of course, we will need to get our propeller on, and yeah, then let's just throw it and see. The maiden is next. In the maiden, what we will be doing is an auto tune. So what I will show you actually is something that will be handy for the auto tune to put on an OSD. So let's connect, and what I'm going to do is go to OSD number 3, which is our last OSD. And what we're going to do is down in this adjustments section, what we want is our pitch and roll PIDs. So if we set these up on screen, we're not going to actually be adjusting anything, but it will give us information. We want our rates, where are they? All right, stabilized pitch rates, stabilized roll rates. And basically when we do the auto tune, these settings will change. So what we're looking to see is the last two numbers here are the feed forward, and these are obviously our rates. So you can see by default our pitch rate is 90 degrees per second, our roll rate is 180 degrees per second. They're shown in increments of 10 degrees on here. And we have our pitch feed forward of 95, which is what I adjusted to. Of course, you will need to change this based on your actual setup. Don't just use mine. And we have our roll feed forward of 50. These are the values that auto tune will actually change. And the reason we're putting them up is so that when they stop, we know that the tune is about right. But yeah, it's well worth putting on here settings that we will need to keep an eye on as well. So I'm going to add ground speed. So we want a cell voltage just to make sure our battery has power left in it. Throttle position, because we want to do this, maybe it's sort of 60% throttle. Flight mode, because we need to be in acro when we do this. And I'm just putting up basic settings, altitude, so we can just keep tabs on that. I will put the numeric vario, and we'll put our fixed wing level trim up there as well, seeing as we have our digital vario. So yeah, that should be a decent amount of information for when we do the auto tune on the last OSD. So the main ones are the pitch and roll rate, the pitch and roll feed forward. We want to make sure that you have our ground speed, our altitude, our battery voltage, throttle percentage, flight mode, which I can move over a bit. RSSI we don't really need, but it's handy to have. But our digital vario, our level trim, and yeah, that should do us for the auto tune. So I will try to get this video out as soon as possible, but I am going to be limited by the weather and availability of where I fly. If it's hammering down with rain, which it looks like next week is all rain, so I will try to get this video out as soon as possible. But I hope this video has been helpful, guys. I know it's a lot of information to take in, and some things I have sort of glossed over because they're not really needed for this beginner level. I do have a video on how to set up INAV from scratch, where I've gone over it in sort of a bit more detail. But as long as we get the basics done and we go through that pre-flight checklist, then all should be golden. And the most important things with regard to the flight controller orientation, the settings of the transmitter on the receiver page, and checking the control surface movements in both manual and a stabilized mode, plus checking the stabilization direction is correct. That's yeah, a big part of it. We've also checked the failsafe will work. We've set up our return to home. So we're pretty much there. But as I say, just go through that pre-maiden checklist and just double check that everything is set up ready to go. Thank you very much for watching, guys. If you have enjoyed this video, please remember to give it a thumbs up. and click the subscribe button and bell icon. That will help get this video out to more people so they can learn about setting up their first plane with INAV 2. One other thing, I get asked quite often if I have a Patreon or any way that people can thank me. If you go on my website, there's actually a thanks and support area that lists everything in there. But basically, yeah, there is a Patreon. There is sort of one-off ways of thanking me as well. So, you know, it's the information's there. I don't want to force it on you guys. If you feel like that's something you want to do, thank you very much. But don't feel like you have to or anything like that. But yeah, thank you for watching, guys. See you on the next one where we're gonna get in the air and have a blast. See you. Bye.